Welcome to the Thunderbolts.info podcast for December 26, 2015. One might say that today's episode has been 1 year in the making. We're going to be taking a look back at the biggest space news stories of 2015 that we've covered here on the Thunderbolts YouTube channel. I would say that perhaps more than any year in recent memory, the space news headlines around the world were typified by the continuous expression of surprise and perplexity by investigating scientists. Of course, the year began with the first science papers from the Rosetta mission to Comet 67P, and even well before the landing of the Philae probe on the comet nucleus, we had a number of enormous surprises for comet scientists, everything from the basic double-lobed form of the comet to the completely desiccated appearance of the comet terrain. As the probe approached the nucleus, we began to see features that have no business, from a conventional viewpoint, being on a comet nucleus. Features such as sand dunes and fields of rubble and boulders, and other planetary features such as towering cliffs and mesas. We'll be talking about the evidence presented in the most recent Rosetta papers as we move along in our discussion. And of course, we had the New Horizons mission to the dwarf planet Pluto. And again, the discoveries were really striking at the foundation of the long-standing theory of the solar system's history and formation. Tonight, we're going to be talking with the chief science advisor to the Thunderbolts project and the leading proponent of the electric universe, and that is Australian physicist Wal Thornhill. Now, Wal, as always, you were extremely busy this year. You were giving lectures in many countries around the world, and you gave a very well-received talk in Phoenix in June of this year at the EU 2015 conference called The Long Path to Understanding Gravity. I mentioned in my opening some of the surprises that were revealed by the Rosetta and Pluto missions, respectively. So starting off here, why don't you tell us about some of the surprises revealed by these missions that stand out most in your mind, and what do you think can be cited most confidently as an affirmation of the predictions of the electric universe theory?
I think, as you discussed, particularly with Comet 67P and with the dwarf planet Pluto and its moons, it reinforced, I think, even more than I expected, the fact that these bodies show planetary features, which you would not expect on those objects that are supposed to have been formed in the outer reaches of the solar system from aggregations of dust and ice. They have quite complex surfaces. They show mountain ranges on Pluto and also canyons, and also even things that look like sand dunes on both bodies. And just recently, in the last week or so, there have been released the most detailed close-up pictures of the nucleus of Comet 67P. And what we see there is a very complex surface, one that has been scarred, not by collisions, because the scarring looks far more familiar to somebody who's been looking at pictures of electrical scarring under a microscope. And that is the circular features, the craters, the sharp edges, the sharp peaks, and there's even evidence of layering, I think, on that comet as well. All of these fit with the story which the electric universe has been piecing together over many decades, and that is that all of these solid bodies, comets, asteroids, and planets, and dwarf planets as well, are all formed at roughly the same time as the stars in the cosmic birthplace, which has now been witnessed by the infrared telescopes in space, the Herschel telescope and so on. And we see that these objects are formed in long strings which look like slow motion or stop motion lightning in a cloud. They're very long, thin filaments and these bright spots where the stars are forming. But of course, if we could look closer, the electric universe says that you would also see smaller bodies strung along those filaments, and that it is only when the filament fades, as Hans Alfvén said, that gravitational systems are the ashes of prior electrical systems. And so planets and so on are then captured by the stars, or are formed so close to a star that they go into orbit as soon as the electric discharge phenomena subsides. All of this fits. Pluto shows evidence of having a complex planetary history, All planets have a history based on the electric universe model because they have their own stories of formation, capture, and subsequent rearrangement and interaction with other bodies in the process of trying to form stable orbits. And of course, the moons of Pluto were described as being in pandemonium. Now, this shouldn't have been the case if Pluto and its tiny moons were all formed in the same circumstances and in the long distant past, billions of years ago. They all show evidence of having been formed, captured, suffered some event recently. When I say recently, you can probably talk in tens of thousands, hundreds of thousands, or maybe at a stretch a few million years, but certainly not billions of years.
Yes. Now, before we move on to Pluto, I thought it would be good to focus on Rosetta for a few minutes. The term Rosetta itself, I think, kind of showed the belief system that was at stake when the mission was originally designed. Rosetta is referring to a kind of Rosetta Stone. And of course, the expectation was that through the study of this comet, we would actually be gaining insight into the formation of the solar system. But we've already talked about some of the original surprises that fly in the face of that reasoning. But it's interesting because even as all of these surprises were being revealed and we saw the science headlines emerging around the world, we still saw the same original story being pontificated as if it's established fact, and that is that the solar system formed about 4.5 billion years ago, and the comets are the leftovers, that they're these aggregates of ices and interstellar dust. But more recently, we've been presenting the material of Dr. Franklin Anariba, who is a specialist in electrochemistry, and he's been delving into the more recent Rosetta papers. And we've talked about things like the evidence for electrical activity at the comet. We've talked about the discovery of electrons and electric fields at and close to the comet nucleus. And they've discovered the ejection of high velocity, negatively charged dust particles from the nucleus. So why don't we talk a little bit about that? I'm sure you've been reading and keeping up to speed on the Rosetta papers. What are your thoughts on some of the more significant discoveries that have been revealed by some of the really fine evidence that have been uncovered by the space probe?
Well, I think the very nature of the jets that have been observed coming from the comet nucleus suggests something other than just a gas sublimating from below the surface. If that were the case, you would expect to see clumps of material and also a more dispersed explosion of material from the surface. And that's not what we see. We see highly collimated jets of very fine dust. And the strange thing is in all of this that it seems that when you have a fixed idea of what you expect to find, you tend to forget earlier discoveries that don't match your beliefs. And in the case of comets, the production of very fine dust was remarked upon as far back as the very first cometary encounter with Comet Halley. And it was remarked upon, and the surprise then was very great, as it always seems to be, that such fine dust could have been produced by gas blowing material off the comet nucleus. But of course, the electrical machining of material from the comet surface does produce very fine sputtered particles of the rock material. And of course, this is the kind of thing that Franklin Anariba has been examining, the kinds of chemical reactions you expect between the atoms that make up the rocks of the surface of a comet. And I say rocks advisedly because this was one of the major predictions of the electric universe, and that is that all of these bodies are of planetary material and will have had a kind of planetary history, so that you would expect the same minerals to be found on a comet as on a planet. I mean, this was confirmed by the Stardust mission, but seems to have been forgotten. Once again, when facts don't fit your beliefs, they are swiftly forgotten. And so these continuous expressions of surprise are partly a result of a kind of amnesia that results from results you don't want to hear.
Right. One of the more interesting things I think we've been able to present visually in the Space News episodes is the expectations that comet scientists were bringing to the earlier comet missions. You mentioned the mission to Halley in, I believe, 1986. And there was a graphic illustration of what scientists expected to see when they were able to image Halley. And it was a very smooth, snowy kind of surface. It did, of course, actually resemble a snowball. And now we're presented with this desiccated and very rough and rocky terrain that we see on Comet 67P. But as you've discussed many times, one of the major sticking points for scientists is their measurements of the density of the comet nucleus. Now, what are your thoughts on that? Why is that such an important issue, and why does that have actually some really important ramifications even beyond comet science?
Absolutely. This goes to the very heart of our lack of understanding of gravity. The scientists, the mathematicians, and Einstein, of course, is the most notable example, produced equations to describe what is observed, and it works for the solar system. And of course, the gravitational so-called constant is measured on the surface of the Earth. But it's a rather unfortunate fact that mathematicians are not necessarily scientists, and so they have a tendency to apply their equations where they're not actually applicable. And assuming that the gravitational constant for the Earth applies throughout the universe was one of the most incredible and arrogant pieces of hubris on the part of scientists or mathematicians imaginable. The fact is that scientists still have no good explanation for why matter has mass. And the primary indication for that is that they've spent probably in excess of $16 billion now on the Large Hadron Collider trying to find a particle which they think gives matter its mass. But that is really one of the most silly ideas I've ever heard. I mean, the thing that you would imagine is that matter has mass intrinsically for some reason, but that has to be found out. Now, the electric universe has, at the last conference this year in June, I actually presented what I think is a model of a theory for gravity. And the main argument there is that you have to specify the scale upon which you're working, because in the electric universe there is only a single force, and that's the electric force. It just manifests at different scales in different ways. And in the case of gravity, it manifests on the scale of the solar system, and that's about it. Once you get to the scale of galaxies, that's the electromagnetic forces involved in the electric currents flowing into the spiral arms and into the center of the galaxy. That controls the motion of a galaxy, and that's why it rotates more like a solid plate than it does a gravitational system.
Right.
And of course, when you get down to the other end of the scale, down to atoms, it's the electrical forces between the particles themselves which dominates. And this is one of the reasons you can't do gravitational experiments very well in the laboratory, because the force is so weak that it's practically unmeasurable. In the case of Comet 67P, we had the assumption, of course, that big G, the gravitational constant, is the same for the comet as it is for the Earth, and that is not proven, and in the electric universe it is not so. Therefore, whatever you measure by the motion of your lander and the spacecraft around in orbit around the comet, you can measure this gravitational force. But if you apply the Earth's gravitational constant, it will give you a ridiculous answer for the density of that object, and therefore its mass. The electric universe says if it looks like rock, it is rock. It's mostly rock.
Right. Well,
Regardless of what you measure gravitationally. It's simply because you cannot apply Newton's law of gravity willy-nilly based on the measurements we do on Earth.
right. Well, that brings up another interesting issue. There's also the question of the possibility of the hollowness of a comet. You've discussed before how, for instance, in electrical discharge experiments, I believe it was C.J. Ransom who found that the spherules that he created by blasting hematite with electric arcs, many of these spherules were actually hollow. Do you think that a hollow comet is a real possibility?
Yes, I do. The very fact that a great proportion of asteroids also have that lobed appearance. I mean, there's been many radar pictures taken of asteroids flying past the Earth-Moon system, and most of them show a peanut shape, a double-lobed shape. So the fact that Comet 67P also shows the same shape is also an argument for the fact that both asteroids and comets are the same kind of thing. It's just that their orbits are different. The hollowness argument, I think, can be supported because one of the aspects about gravity that's not understood is that, of course, as I said, Newton's law of gravity applied to the Earth-Moon system and the planets and objects falling to the surface of the Earth. But it still doesn't explain why the Earth pulls us to it, even with this very weak force. The electric universe says that what happens is that the electric force itself is responsible for gravity. And in the case of the Earth, the positive charged particles, all of the positive charged particles and all the atoms on Earth are about 2,000 times heavier than the negatively charged particles or electrons that make up the atoms. So in a gravitating body, once you've formed it in one of these electric discharge events, which coalesces the objects to form planets and moons and whatnot, the object that you've formed now has a tendency to pull all of the positive charge towards the center and the negative charge facing outwards, which is equivalent to a magnet, if you like, with one pole facing inwards and the other pole facing outwards. And we and everything on the Earth's surface is pulled towards it just like a ball bearing is to a magnet. However, this gives you a picture of what's going on inside planets and inside stars, and that is that there is a repulsive force between the inner regions, which can form. It is plausible to suggest that many of the objects in space could have hollow centers.
Right. Well, it's interesting. I think some in our circle have actually pointed out the curiosity that we have these double-lobed bodies that we see in the solar system. I believe 4 of the 7 comets that have been imaged have actually had that same basic appearance, and now we have 2 double-lobed moons in the Plutonian system. But also, you see that kind of hourglass figure among nebulae.
Yes, this picture of gravity as being a dipole force is extremely interesting because it supports Helton Arp's observational work, which suggested that the visible universe is static. It's not expanding. I mean, the idea of expansion comes merely from interpreting redshifted light as being due to velocity. But there is another mechanism that can explain it. Once you discard the idea that redshift has anything to do with velocity, Helton Arp said the universe appears to be in equilibrium. And that raised the issue for him of how do you manage this without having gravity as a repulsive force as well as an attractive force? Well, the electric universe provided the answer at that conference this year, and that is that all solid planets, moons, stars, and so on exhibit the same pole facing outwards. And if you can imagine magnets having only a single pole and it's all the same, say a north pole or all south poles, and you try and push them together, what are they going to do? They'll repel one another and they'll find some balance. And this is the key to having a universe in balance. The Big Bang Theory, with only an attractive force of gravity, is completely unstable. It either expands forever or it expands for a while and then collapses back in on itself.
Right.
It's a nonsense story. But having this picture of gravity as a dipole force, very much like magnetism, then you suddenly have an answer to that conundrum, and it's a simple one.
Well, you mentioned Halted Arp's work. We in the past, we've done a lot of space news reports on, for instance, objects that are apparently impossibly huge, or we see objects that have impossible brightness. These discoveries, it seems that they're noted and then things just move forward. The narrative doesn't ever actually change.
This gets back to what I said before. When it doesn't fit your belief, it's swiftly forgotten. It's put in the shelf too hard basket and you forget about it. But you can't do that and still call it science.
Right.
Well, one of my favorite space news reports of this last year was about a discovery by the Herschel Observatory. And I think this was one of several fulfillments of explicit predictions by the electric universe. Now, in the book, The Electric Universe, by yourself and Dave Talbot, you guys outlined the electric universe theory and the plasma cosmology theory for star formation. I actually have a direct quote in front of me. You guys wrote, plasma physicists argue that stars are formed by an electromagnetic pinch effect on widely dispersed gas and dust. The pinch is created by the magnetic force between parallel current filaments that are part of the huge electric currents flowing inside a galaxy. Now, it was reported this year that throughout the Milky Way galaxy, we see a filamentary network. And it was reported that these filaments are intimately connected with the formation of stars. And so this was a big surprise for investigators, but I know this wasn't a surprise to you. So what was really so striking to you when you saw this report in science media?
It seems the only answer that the traditional view of star formation has is that these filaments are actually boundaries between regions where there's a shock wave traveling through. And so what you're seeing is the sharp edge of the shock wave. But that will not give you a constant width over tens or hundreds of light years, which is exactly what is seen. And also, this idea of shock waves requires supernovae explosions going off in various places, which would tend to give you, I think, more curved circular profiles, you would imagine, like the edges of bubbles. But what we see looks exactly like cloud to cloud lightning with its rather sharp excursions and side tributaries, the filaments that extend from the main filament, this kind of thing. It is not what you'd expect from shock waves passing through media. But once again, also, we know from observing lightning on Earth that when you have lightning travelling through a cloud and then to ground, it maintains its width over many, many kilometres. And of course, scaled up to the scale of stars and planetary systems, this is exactly what we're observing. It's just a scaled up version of a lightning bolt in a molecular cloud.
Well, it's always been curious to me when we read about these just stupendous electromagnetic outbursts of energy, things like gamma ray bursts, and trying to explain that using the force of gravity and trying to explain that in terms of explosions and use the term shockwave. So, why is it that it seems, at least to a layperson like myself, that seems so counterintuitive using gravity to explain an electromagnetic event? So why is it that there is this kind of inertia where these obviously electromagnetic phenomena in space are still explained purely using the gravitational force?
Well, somebody said when all you've got is gravity to explain things, all you can have is collisions and explosions. And even the explosions are not well explained. Supernovae explosions have been discredited by some scientists looking at three-dimensional explosions and saying that it wouldn't reach the surface. In other words, the star wouldn't actually explode. And the theory of explosion of stars is extremely complicated and unlikely. But the electromagnetic picture of stars and galaxies has been done in peer-reviewed literature by plasma cosmologists in the IEEE, the largest professional organisation in the world. But because it's not part of the astronomical catechism, the astronomers don't attend. And yet the plasma cosmologists have had the most success in explaining the observations that have come in recent years. And when you go back and look at some of the pioneers, they were saying back in the early 1900s, Charles Bruce was one of them who explained planetary nebulae in terms of an electrical discharge phenomenon. And he was even one who pointed to the photosphere of the sun as being equivalent to a whole lot of lightning bolts in parallel. And being an expert both in electrical engineering, he was a doctor of electrical engineering and also a fellow of the Royal Astronomical Society. So he covered both fields and was an expert in both fields. And his view was that the sun is basically an electrical discharge phenomenon based on its spectrum and also its behavior, the behavior of the photosphere. But these people, of course, are ignored because it just doesn't fit the story. And this is one of the problems that we face. It was always thought that science was trying to distance itself from religion by being objective and testing ideas with experiment and so on. But in fact, we have not yet learnt how to separate the two.
Right.
So modern science is as much a religion as any other. It is just as difficult to convert people from that kind of thinking as it is to convert somebody from one religion to another.
Well, speaking of converting people, I don't know if that's what was happening at the most recent EU 2015 conference, but there are some recent converts that came, and we have a lot of interested younger people and people from a great variety of backgrounds. Your presentation, as you mentioned earlier, was called The Long Path to Understanding Gravity. And you've been able to kind of sit back in the aftermath and look at how your talk was received. And we have, of course, the wonderful medium that is the YouTube comment section, and you've been able to follow some of the responses. What are your thoughts about the reaction to your talk? And are there any kind of misunderstandings that you think you would like to kind of take a shot at clarifying?
Yes, thanks for that question. I do go through the comments of those YouTube videos. I don't have time to respond, or I don't want to get involved in discussions because usually it's only part of what I'm doing. But there was one aspect of my talk which I now look back and think I should have spent more time explaining. It was in the last few sentences of my talk, and by that time I was beginning to run over time. And that was where I talk of the idea of gravity inside the Earth being repulsive. And one of the comments was that you're more or less arguing in a circle, because how do you form the Earth in the first place if you've got this repulsive force? And the answer is, as I mentioned earlier, you have to look at the scale at which you're operating and what forces are dominant at that scale. And in the case of the formations of planets and stars, and this is why I say they happen together, it's in those electromagnetic pinches where the electromagnetic forces far overwhelm the puny gravitational force. And it's in that environment where all the matter is drawn together and the heavier elements are in the center and the lighter elements towards the outer edges and the hydrogen and helium right at the outside. That is where planets are formed. And it's under those conditions of electromagnetic compression that the object is first brought together and the gravitational field of that object is established. So that gets rid of the circularity argument.
Right.
And that's the most critical thing to understand about gravity, is that you have to talk about the scale that you're operating at. And as I said, it's only really valid, as we understand it at present, on the surface of the Earth, above it, and to the outer reaches of the solar system, maybe the nearest stars. But beyond that, electromagnetic forces are dominant, and that's what forms spiral galaxies with their different rotation, which is non-gravitational.
Well, I think one example you give that I think is easily understandable even to a layperson is within our own neighborhood in the solar system. You've pointed out that if gravity is the only operating force, then if there's the slightest disturbance to a planet's orbit, then there's nothing to correct it or to prevent it from going into chaos.
That's correct. And astronomers know this, but it's one of those things that is swiftly forgotten. There have been calculations done by reputable celestial dynamicists, and they have shown that the stability of the solar system cannot be guaranteed beyond a few million years. And
Right.
yet we're talking about the solar system and what it was like billions of years ago. We talk about eras on Earth and on Mars and so on, which extend back 2, 3, 4 billion years, and the moon with its bombardment after it was formed billions of years ago. You can't do that. But, of course, in the electrical model of gravity, you find that the masses of planets are actually altered if they come too close together and they exchange charge in the form of those mythical thunderbolts of the gods. The charge transfer is massive, the change in mass is marked and sudden, and as a result, by conservation of energy requirements, the orbit of those two planets change. And they change in a way which avoids collision. And then there's the other aspect, of course. If all objects look like a single pole of a magnet, they will also gravitationally repel one another up to a point when they get close enough together. So they avoid collisions. So the standard model of collisions and explosions fails on the collisions side as well.
Yes. Well, of course, the electric universe community is very interested in the latest findings at Pluto, including the discovery that the Plutonian system is surprisingly chaotic. In fact, the word that the investigating scientists have used to describe the motions of Pluto's satellites is pandemonium. So, how do you think this finding speaks to your theory of the more recent electromagnetic capture of planets and moons?
What I'd suggest is that there are many objects in the solar system right now that are remnants of the last capture event by the sun. And of course, one of the aspects of the electric universe model is that there is electrical exchanges during capture. The body entering the solar system will become a comet. A comet is an electrical discharge phenomenon which will exchange energy in such a way as to capture that body, or at least render capture far more probable than the gravitational theory, because in gravitational theory, an object entering the solar system will swing around and then exit again. There's no means of transferring energy unless it hits something. But the electrical model says no, it will be captured, or its orbit will be modified greatly by electrical exchange. That also fits with ancient records of the Venusian cometary behaviour. And Venus today has the most circular orbit in the solar system. And yet it was witnessed as a comet by human observers, probably in prehistory, but there is a strong memory of it right down into historical times. This combination of electrical exchange and change in mass and orbits is the stabilizing influence required, absolutely necessary to give us our so-called clockwork Newtonian solar system. Pluto and its unexpected atmosphere and unexpected moons and unexpected planetary features all argue strongly for having been, until recently, a member of a marauding system which was captured by the sun.
Right. Now, while we're coming to our close here, looking ahead to 2016, do you have kind of a general feeling about where we are in terms of the progress of the electric universe? I wouldn't ask you necessarily to make any predictions. How do you see things unfolding for us in the electric universe community in 2016? What do you see just over the horizon?
Well, the theme for the conference next year is elegant simplicity. And it struck a chord for me because I had recently witnessed Neil Turock's presentation at the Perimeter Institute in Canada, which is a leading think tank, I suppose you would call it. And he was talking about simplicity in science. Yet what did he do? He started with Pythagoras' theorem, and in front of a board covered with mathematical symbols and whatnot, he then proceeded to progress to the point where he had an equation on the board which no one could interpret, but he said was the closest they had to a theory of everything. This is absolute nonsense. It is not the way to do science. The electric universe starts from the simplest basic models and then progresses upwards, and at each scale the dominant forces are different and therefore the manifestations are different, but the complexity of the universe starts from something very simple and then becomes more and more complex and interesting as we observe it, as you go up in scale. And I think when you begin to understand that, and also you understand the other critical thing, and that is the connectedness of everything. You know, we have this sense that things are connected, but science tends to pull things apart and then look at the individual parts. But once you realize that even the experimenter is part of the experiment, then a lot of the mysteries in modern science fade away, and you begin to understand how we fit in this electric universe.